plus exam. I'm going to show you guys how I study through the process of studying itself, because the best way to learn something, in my opinion, is by doing and by seeing, like observing somebody doing it and then like doing it yourself. So we're actually almost I'm almost done with the entire study guide. Learning 5.1, explaining the troubleshooting methodology. So just a quick rundown of like what I do and how I do it. I have a ChatGPT thread, and I have like a little prompt here that I created. So ChatGPT or any type of LLM is really good in order to like learn. It's one of my favorite things to use of like all time. It's my favorite things to use of all time. It's like the ultimate teacher. So my prompt is, I'm studying for the CompTIA Network Plus exam. I want to go through each question one at a time from my official study guide. For each question, I want to do the following. Okay, tell me the correct answer, even if I guessed wrong. Use 5-part method. Explain by restating the question. Give me a simplified answer, an analogy, an in-depth example, real-world. In-depth explanation, and then a real-world example and/or scenario. If I ask a follow-up question, stay in this format until I say the next question. Do not move on unless I say so. Always wait for me to say next question or next section. We'll start with blah 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 blah. Okay, now we're not there anymore, so what I need to tell it is that we are now moving on to section 5.1, examples and explaining the troubleshooting methodology. So you basically have to talk to a large language model, especially ChatGPT. You have to talk to it as if it is a high school student. It needs to be told 100% exactly what it's doing. Okay, it can't be left for interpretation. If you leave it up for interpretation, it's going to interpret it wrong, most likely. So the next thing I do is that I also have another AI here, Speechify, that reads me things.
When following standard troubleshooting guidelines, an IT support technician asks a user, did it ever work? And when did it last work? These questions help with which of the following troubleshooting approaches when identifying the problem.
So this follows alongside the CompTIA A+ troubleshooting method. So when the following standard troubleshooting guidelines, an IT support technician asks, did it ever work and when did it work last? We're documenting findings and actions. Here, you know what? We'll just have it read it to us again.
Document findings, actions, and outcomes. Test the theory to determine the cause. Determine if anything has changed. Establish a theory of probable cause.
So normally I would, since I'm going through it for the very first time, if this is not, what's the word? If the answer isn't blatantly like coming out at me, then I usually just hit like, I don't know. Or even if I do know what the answer is, like you can go over here and you can click it like, I'm unsure. Sometimes I'll still do this because when you go back to the review, if you get it 100% right, it's not going to go over the question. Sometimes it's not the question that I don't know, it's the other answer choices that I don't know. So this obviously is talking about some type of like methodology and a series of steps and a hierarchy of pathway in order to do this. So I think what we're trying to do here, did it ever work and when did it last work? Determining if anything has changed. I think it's determining if anything has changed because I'm establishing if it had ever worked, and if it did, when was the last time it worked? Testing a theory to determine. We're not testing a theory yet, and if you are testing a theory at this point, then you have a conception of the problem, which you might not want to go into like that. Document findings, actions, and outcomes. Maybe. Establish a theory of probable cause. So in most tests, there's always a throwaway. This is the throwaway answer. I don't think that's right. Okay. The other one is that there's usually 3 answers that are correct. or could be correct. So documenting findings and actions and outcomes. Well, this makes sense because if I'm trying to document any type of findings, then like I need to know if it ever worked. Like this is like me gathering intel, and that's exactly what these questions are. Determine if anything has changed. Okay, this is also the same thing. Like I didn't just ask one question. Like if I asked one question, sure, I'm trying to get findings and actions. This is determining if there was a change. So I actually think it might be one of these two, establishing a theory of probable cause. The third answer is something that sounds right, but at the same time probably isn't right. You know what I mean? Whoops. Knock that down just a little. Okay, fantastic. So we'll go here. Yeah, see, and one of those were right. So that's basically what I do. Let's see if we can get through these really quick. There seems to be quite a lot of them.
A technician determines that a faulty network connection caused a system error. Which logical approach allows for methodical steps to diagnose the cause?
It's either identifying the problem or gathering information. Ooh, I was wrong on both. I don't put anything in ChatGPT until I get into the review section.
When changing a system as part of implementing a troubleshooting solution, which of the following practices should be followed? Select 2.
Implementing a troubleshooting solution, which of the following practices should be followed?
Select all that apply. Record all changes made during the troubleshooting process.
Yes.
Make changes without backing up data and configuration. Test after each change to ensure the problem is resolved. Implement all suggested solutions simultaneously to save time.
No, you don't want to. Okay, yeah, you don't want to make changes without backing things up. That's recipes for disaster. And implementing all suggested solutions simultaneously to save time. That's also a bad thing. But again, I'm gonna hit unsure, and that was correct. This also means that I'm going to see this question 2 or 3 times because I hit that I was unsure. So that means that like I'm going to just retain that information higher.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
I think the music's at a good level. No, I don't know. I just want to make sure that I'm not overpowering things. Here, this will be a test real quick.
Implement preventative.
Do the thing. Man, the delay is bad. Ooh, that is loud. I don't know if I can adjust that volume. Also, don't know if I'm gonna dox myself real quick. Okay, I guess I can't. So then let's, we're gonna make this like really quiet. And that should be fine. Okay, cool. What was the question again? What are we doing? A sysadmin is reviewing. Yeah, that should be fine. Okay, sysadmin is reviewing an alert from a firewall that a piece of malware was downloaded onto a computer on the network. What steps? Okay, so first one is that we need to establish a plan of action. No. Determine if anything has changed. confirm a theory, implement preventative measures. So implement preventative measures and determine if anything has changed. That's the first two things. Let's see. I was wrong.
Troubleshooting a site that is no longer responsive. Which of the following is the last step the operator should perform?
Okay, help desk operator is troubleshooting a site that is no longer responsive. Oh, I'm gonna say implement the solution. What is the last step to perform? Implementing the solution. No. Okay. Learning a lot about problem solving.
Physical server has been plugged in, powered on, and networked into the communication closet. Using a KVM key video mouse device, the network technician notices there is no network connectivity. Examining the back of the server, the LED status indicators for the port are off. After identifying the issue, establishing a theory of probable cause, and testing the theory, which course of action should the network technician take next?
After identifying the issue, establishing a theory. So there's very clearly a hierarchy. Maybe if I would have got the textbook, I would have read it and I would know what it is. So, but I don't know what that hierarchy is. That's a question that I'm gonna have to ask ChatGPT or just Google in a second. So after identifying the issue, establishing a theory of probable cause, and testing the theory, which course of action should the network technician take next? So if he's identified the issue, he's established, hey, this is probably what's happening. And then he has tested the theory.
Step 1. Document findings. Step 2. Establish a plan. Step 3. Implement a solution. Step 1. Test the theory. Step 2. Implement a solution. Step 3. Document the outcome. Step 1. Establish a plan. Step 2. Implement a solution. Step 3. Verify network connectivity. Step 1. Verify system functionality. Step 2. Implement a solution. Step 3. Document the outcome.
I don't know when the documentation comes in. I'm going to assume you have a theory, so then now establish a plan, implement a solution, verify network connectivity. I would imagine it's either this one or this one. Verify system functionality, implement a solution, and then document the outcome. Yeah, one of those is correct. Okay, that makes sense. When troubleshooting network issues, what is the first step to resolving it? Establish a theory, identify the problem, establish a plan of action to resolve. Obviously, you have to identify the problem. I was going to be really upset if that one was wrong.
A technician tries the suggested troubleshooting steps to remedy a computer issue. The steps do not fix the problem. The technician discovers additional suggestions at a support website that provide a different cause and potential fix for the problem. What troubleshooting path should the technician follow?
Duplicate the problem if possible, document findings, actions, and outcomes. If the theory is not confirmed, reestablish a new theory or escalate. Okay. Escalate means that it moves. It moves up the hierarchy of troubleshooting. So you basically you pass it on. You don't just pass it on to another person. There's levels to it. So that way, people who just need their password reset, or there's an issue or something like that, those people get taken care of by that's a level 1 issue compared to I think I have malware and it's hacking into the system type thing. That's going to be at a higher level. Establish a plan of action to resolve the problem and identify. No, I'm pretty sure it's this one. Yes. Okay, cool. Let's learn. See, now this is why I really like the CompTIA stuff, because it gives me all of this. So what we're going to do is we're going to copy and paste this. I'm going to come over here. I'm going to say next question. And then I'm just going to get rid of correct and incorrect and unselected. I don't need that. I wish there was a way for me to okay, and then while that generates, yeah, we're good. Okay, while that generates, we're gonna reread the question again.
A technician determines that a faulty network connection caused a system error. Which logical approach allows for methodical steps to diagnose the cause?
The OSI reference model guidance. So that must be like what the name of the thing is.
The troubleshooting process can be broken down into categories using the OSI model as a guide. Start from either the top or bottom and only move up or down when a layer has been discounted as the source of the problem. Escalation means referring the problem to a more knowledgeable entity, such as a senior technician, manager, or third party. It is important to take enough time to determine what has caused the problem, so that a recurrence can be avoided. Identifying the problem includes a variety of steps that help to understand what is and is not working. Gathering information is an important first step in identifying the problem. This step may include documenting system and software details and specifications.
Okay. So it's using the OSI model as the model for guidance in terms of troubleshooting, trying to narrow down which one in these 7 layers of the system that it is. Is it a layer 2 issue? Is it a layer 3 issue? Is it a layer 1 issue? Things like that. Okay, so that makes sense. Let's see what ChatGPT has to say.
Great. Here's the full 5-part breakdown for this troubleshooting methodology question. 1. Restate the question. Which logical approach allows a technician to follow methodical steps to diagnose the cause of a system error due to a faulty network connection? 2. Simplified answer, identifying the problem. 3. Analogy. Imagine your car won't start. The first thing you do isn't replacing random parts, it's to identify the problem. Is it the battery? Is there gas? Does the engine turn over? Only after identifying the issue can you logically move forward. Same goes with network troubleshooting. The first step is figuring out what's actually wrong. 4. In-depth explanation. In the CompTIA troubleshooting methodology, the first step is always to identify the problem. This involves gathering information, logs, error messages, user reports, questioning users, observing symptoms, determining what's working and what isn't, reviewing recent changes, possibly duplicating the issue if safe. The other choices, gathering information is a subtask within identifying the problem, not the entire step. Escalating as necessary is done later, when the problem exceeds your scope or permissions. OSI model guidance is a helpful framework for narrowing down where a problem occurs, for example, physical versus application layer, but it's not a step in the troubleshooting process itself. The methodology must start with clearly defining what the actual issue is, otherwise you risk wasting time or making things worse. 5. Real-world example or scenario. A user says, "I can't access the internet," before replacing hardware or rebooting systems. The technician first checks if other users are affected, tests the user's connection, pings external IPs, looks at recent network changes. Through this identification process, they find out it's limited to a single port on a switch, revealing a faulty cable or switch port. That's the result of applying step 1, identify the problem. Let me know if...
Okay, so this is why I like using ChatGPT, because it got it wrong. Okay, and it thinks that the answer is identifying the problem, and I also thought that identifying the problem or gathering information was correct, but that's not correct. The correct answer is the OSI model of reference model guidance. The OSI reference model guidance. Okay, so why I like this is because, and it's kind of scary, like it's thinking like a human, where it's like, well, it obviously makes sense, but it got tricked by the question as well. So now what I'm gonna do is I'm gonna say the network plus study guide says that it is, I'm just gonna copy and paste that, it's gonna be so much easier. Oh yes, okay, it says it's this. So I'm gonna tell it like, hey, like you're wrong, the study guide says that it's this thing over here, and it's gonna be like, excellent observation, like blah blah, and then it's going to explain to me why that answer is correct in terms of the study guide. And then it's going to break down, and usually it'll catch its mistake and say, well, the question is actually saying this. Yes, definitely class time. Sorry, I'm not really reading chat. I'm studying. So like ChatGPT is like literally the ultimate teacher. Like I'm actually a high school teacher. I'm going to be without a job in like 5 years because this thing is so incredible. So let's see what it has to say about this.
Excellent observation. Let's carefully address this using your 5-part method and reconcile the difference between what the study guide said. 1.
And note that my 5-part method is just a prompt that I gave it. So like It's stupid. It's like it's a high school student. It's only going to do exactly what you tell it to do. So you have to tell it exactly what to do. Do not leave it up for interpretation. And it's not an actual human, so it's not like you can like sometimes leave it up to interpretation for them to like learn how to think for themselves. It's never going to think for itself, or at least I hope it doesn't. I mean, I do hope that the AI learns to think for itself. Okay. But the point is that you want to make sure that you give it exactly what it is good. I have you on the background of my classes right now. Oh, nice. Very nice. Very nice. Learning two different things at once. Anyway, let's see what's going on.
Restate the question. Which logical approach allows for methodical steps to diagnose the cause of a system error caused by a faulty network connection? 2. Simplified answer. OSI Open Systems Interconnection Reference Model Guidance. 3. Analogy. Think of the OSI model like a layered cake. If one layer is bad, it affects the rest. When a chef technician wants to find out why the cake tastes off, they don't just throw it away. They slice into layers and check each one. That's what the OSI model helps a technician do. Work layer by layer to pinpoint where the problem lies. 4. In-depth explanation. Although identifying the problem is step 1 in the CompTIA troubleshooting methodology, this specific question asks which logical approach allows methodical diagnosis. And that's where the OSI model comes in. The OSI...
And that's exactly what I was looking for. It then just dissected the question. It looked at it again and was like, hey, although this is the most common, like this makes the most sense, it's not asking for that. It's asking for this.
Model, with its 7 layers, physical, data link, network, transport, session, presentation, application, helps technicians narrow down where a problem exists. For example, is it a cabling issue? IP problem? DNS resolution? Take a systematic layered approach rather than guessing randomly. Troubleshoot from either the bottom up starting at cables and hardware or top down starting with applications. That's why OSI reference model guidance is the best answer for methodical troubleshooting steps.
So, and this is one of the reasons why it's saying that, like, if there's a problem, and a lot of times you're probably going to do this all at once, you're going to go through the OSI model starting on layer 1, just like hardware and cables, all the way up to basically user. And you're going to try to identify where that problem is in the model, and then you're going to identify what the problem is. Where is it in the model? And you'll probably do this like immediately, super fast in your head. Or, to be fair, there are layer 3 switches, and a lot of network things do more than one thing now. Like your router's more than just a router. Your router is usually a person's router is a switch, a router, a DHCP server, like a NAT. Like it's a whole bunch of things. Sometimes it's Wi-Fi. Sometimes it's like an all-in-one. So it makes sense. Anyway, let's continue.
Especially when isolating causes in complex networks. Let's contrast. Identifying the problem is a necessary step, but it doesn't describe the actual approach or structure of diagnosing technical failures. The OSI model is the structure that provides a logical path for narrowing down network issues.
Yes.
5. Real-world example or scenario.
Okay.
A user reports they can't access email. The technician applies the OSI model. Application layer, is the email client working? Transport network layer, can they ping the mail server? Are ports open? Data link physical layer, is the Ethernet cable plugged in? Is the NIC working? By moving layer by layer, they find the Ethernet cable is damaged, a layer 1 issue. That methodical progression comes directly from OSI model guidance. Thanks for...
Okay, so this perfect example of this right now is my girl's Xbox remote wasn't working, and it wasn't connecting to her computer wirelessly. So I know what the problem is. I've identified the problem. The problem is the remote, it will not attach, right? So I figured this out because it just hit me like last night actually. Her NIC was unplugged in her computer. Because her NIC was unplugged, her NIC is also her Bluetooth. So she couldn't connect to her computer because her computer didn't technically have that connection. And the reason I disconnected is because she was having internet issues. And when I would, go in IP config to try to see what was going on, I kept getting connected to the Wi-Fi. So I was not able to troubleshoot the internet issue properly. So what I did is I disconnected the NIC so I could like completely pull it away from the internet and troubleshoot the hard line, which was layer 1 by itself, but I forgot to reattach the NIC. So if I would have gone through the OSI model first to determine where the problem was, then I would have been able to actually identify the real issue, which was that the NIC was not plugged into her computer. So this is a real world scenario. I really like this. Okay, so the last thing I do is sometimes to solidify, I'll just read the question one more time.
A technician determines that a faulty network connection caused a system error. Which logical approach allows for methodical steps to diagnose the cause?
Okay, I do that just so that way it's now like a third time that I've heard the question. And then I'll read the answer one more time from CompTIA, like their actual CompTIA answer.
The troubleshooting process can be broken down into categories using the OSI model as a guide. Start from either the top or bottom, and only move up or down when a layer has been discounted as the source of the problem.
I do think it's a little contradictory. I do think that identifying the problem is probably the first thing. I feel like this is something that you just kind of do like immediately kind of thing. But I digress. Let's go to the next one. Now this one I straight up just got wrong.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
Now that I'm looking at it, it makes total sense. Implement preventative measures. That's after you've cleaned the hardware. That's after you've cleaned it. Determine if anything has changed. Confirm the theory. Establish a plan for action to resolve the problem. I think it's pretty safe to say I know why this is going on. Let's see what this has to say.
Since the administrator suspects they know what the issue is, following the basic network troubleshooting steps, the next step is for the administrator to confirm the theory. After confirming the theory, the next step the administrator would take is to establish a plan of action to resolve the problem. The administrator would have already determined if anything had changed in the very first troubleshooting step, identifying the problem. Implement preventative measures is not a basic network troubleshooting step, and is not a step the administrator would perform as part of troubleshooting the issue.
Okay, let's see what ChatGPT says. That makes sense. Now this is again another thing where I definitely understand. I see my mistake. However, I can tell that this question is a much broader question about the hierarchy of problem solving, which is what this entire section is all about. So it's not necessarily that I want to make sure I understand this question. I want to make sure I understand the hierarchy and the order at which that it's supposed to get done.
Great. This question is about applying the correct step from the troubleshooting methodology. 1. Restate the question. A system administrator gets an alert that malware was downloaded on a computer. What steps should the sysadmin take to help prevent this from happening again in the future?
Oh, dang it. I forgot to hit select 2. Implement measures. Make sure that I put all the right ones in here. Okay. Let's try it again. It should poop it out pretty quick. Yeah, the AI that I use is Speechify. It works really, really, really well. You can even turn it so that way it automatically starts playing a response in ChatGPT. And I think I can even have it, I think it's already integrated in ChatGPT. I don't even need it here. It's really handy.
Excellent. Now that it's a select 2 format, let's go through it carefully with your full 5-part breakdown. 1. Restate the question. After detecting that malware was downloaded to a computer, what 2 steps should...
Okay, so again, it immediately thought like me. It thought that implement preventative measures and determine if anything has changed is the correct answer. So let's see why it thinks this, and then we'll see why that's not the answer by saying like, hey, these are their correct answers.
2. Simplified answer. Implement preventative measures, determine if anything has changed. Determine if anything has changed. 3. Analogy. If a security guard catches a thief in a building, 2 smart follow-up actions would be upgrade security systems to prevent it next time. Preventative measures.
See, this is it. This is the exact thing. The follow-up actions. The question didn't ask for follow-up questions. It said, what steps should the sysadmin do to help mitigate it in the future? So it does say that. Yeah, to do this, to mitigate it into the future, so that would be considered a follow-up action. Okay, let's let
measures. And check the building layout or rules that may have changed to allow the thief in determine if anything has changed. You can't just react. You also need to analyze and fortify. 4. In-depth explanation. Let's break down both correct answers. Implement preventative measures. This is the last step in the CompTIA 7-step troubleshooting methodology. After a problem is resolved, you apply policies, patches, training, or controls to reduce the risk of recurrence. Examples include updating antivirus definitions, blocking file types or websites via firewall, strengthening endpoint protection. Determine if anything has changed. This is part of the first step. Identify the problem, and it's critical for mitigation planning. If a new policy allowed more open internet access, or a user installed unapproved software, identifying this change helps pinpoint how the malware got through. It also guides what to fix to prevent it again. Let's briefly rule out the incorrect options. Confirm the theory, that's step 3, used during active troubleshooting, not a future mitigation tactic. Establish a plan of action to resolve the problem, that's step 4, about solving the immediate issue, not mitigating future ones. This question blends past and future thinking, and the correct answers reflect both root cause awareness and forward-looking protection. 5. Real-world example or scenario. A sysadmin gets an alert that malware was downloaded via a browser. First, they determine if anything changed recently. Maybe a software update bypassed the proxy or users were granted new privileges. Then, they implement preventative measures, like adding domain blocks to the firewall, adjusting permissions, and running phishing awareness training. Together, these steps ensure the problem is understood and the path forward is secured. Let me know if you'd like to walk through the 7-step troubleshooting flow, or say next question.
Okay, we're going to do that for sure here in a second, because very clearly we're getting things mixed up. So we're going to let that go. We're going to read, usually the very first sentence or the very first little thing on CompTIA is the answer.
Since the administrator suspects they know what the issue is, following the basic network troubleshooting steps, the next step is for the administrator to confirm the theory.
And there it is. This question is insinuating that the sysadmin already has an idea or a theory of why this is. So the sysadmin reviewing the alert for the firewall that a piece of malware was downloaded onto a computer. So he has a theory, which this is stupid, because like he has a theory that malware has been downloaded onto this computer. Why does he have that theory? Because an alert went off to tell him that the firewall's been compromised. So he needs to confirm the theory. Okay, I guess makes sense. Like, what if it was a false flag? And then establish a plan. These right here are under the assumption that the theory is correct. What if the alert was wrong? What if it was like a false thing? And that makes sense, because how many times are you at school or somewhere else and you try to download something and it's like something harmless, or maybe you're trying to look up a YouTube video or something like that and it's just blocked, and you're like, why is this blocked? Okay, well, the firewall stopped it because it didn't know what was going on. You know what I'm saying? Let's move this up just a little bit so that way we can kind of see the answers just a little bit more. All right, cool. Let's see what ChatGPT has to say about it.
Excellent catch. Let's walk through this again, specifically in light of the CompTIA Network plus Study Guide's answer key. Here's your updated 5-part breakdown reflecting their preferred answer logic. 1. Restate the question. After detecting malware was downloaded to a computer, what 2 steps in the troubleshooting process should a sysadmin take to help mitigate this in the future? 2. Simplified answer per CompTIA. Confirm the theory, establish a plan of action to resolve the problem. 3. Analogy. If you find water leaking from your ceiling, you theorize that it's from the upstairs bathroom. You then confirm the theory by checking for a burst pipe or a running toilet. Once confirmed, you plan how to fix it. Maybe shut off water, call a plumber, or replace the pipe yourself. These are middle steps in the process before resolution or prevention. 4. In-depth explanation. The CompTIA troubleshooting methodology includes 7 official steps. Identify the problem. Establish a theory of probable cause. Confirm the theory. Establish a plan of action to resolve the problem. Implement the solution or escalate. Verify full system functionality. Implement preventative measures. In this scenario, A malware alert has already occurred, so we've identified the problem. The next step is to form and confirm a theory. For example, did this come from a phishing email, an infected USB? Once confirmed, the plan of action is crafted to contain, remove, and restore affected systems. These are the appropriate next steps in the chain before you actually implement or prevent recurrence. The confusion likely came from interpreting help mitigate this in the future.
Yes.
But in CompTIA's framework, you must confirm the cause and plan your fix first. Prevention comes later. 5.
Okay, so going back to my remote control, my Xbox remote control error, this is a perfect example. I originally thought that the problem was the controller, not the PC, and it wasn't until I came over and tried to connect it to my computer, and then all of a sudden it worked totally fine. And well, it didn't work fine actually. I had issues with my Bluetooth because I don't have anything that's connected to Bluetooth. I mean, I have like little dongles. I've like little dongles that get plugged in or whatever, but for the most part, like I don't have Bluetooth. And I actually had to enable it. But I know that my Bluetooth is actually disabled. I don't remember why I did that. It's probably for a stupid reason. But the point is that when I realized that made it go off in my head. So sometimes when you are working on something, wherever you're making a mistake isn't the problem. What happened before that moment could be the problem. So like in the example of the leaky pipe, if I have water dripping from the roof, my first inclination is that the issue is coming from upstairs bathroom. But what if the problem is actually in the attic coming from the hot water heater? I would think that it's from the bathroom because it would be logical sense because the bathroom's right above me. But when in reality, it has nothing to do with that. It's really the hot water heater that is even above that. So that's what's going on. Let's see what its real world example is.
Real world example or scenario. A system alert reveals malware was downloaded on a device. The sysadmin confirms the theory. It came from a user clicking a malicious attachment in an email. Next, they establish a plan of action, isolate the device, remove the malware, scan the network, and patch the vulnerable software. Only after these steps would they move on to implementing future preventative controls. Step 7. Great critical.
Okay, so I'm a big fan of the CompTIA troubleshooting methodology. We are right here. I would like to walk through. Whoa, whoopsie. I would like to walk through the 7-step troubleshooting method. Ooh, flow. I don't want to say flow. I want to say methodology. Isn't that what it's called? Troubleshoot, yeah. In my 5 steps. I really like the troubleshooting process. However, I believe that most people do it so fast that they get confused at where it's supposed to be or what like how things are supposed to go. And I think what's difficult for a technician is that you have to actually methodically go through it, and you even have to document, hey, like I did blank on each one. Okay, we're gonna go through this once, and then wow, this is a lot. I don't know if I want to read all this. I don't even know if I want it to read all of it. Okay. Oh, because it's doing each one. Yeah, it's probably a good idea to go through it all. Oh my gosh, dude, that's so much. It's only on step 2. Good old chatbot GPT. Well, let's start reading through it, I suppose. Is it gonna do it?
Absolutely. Here's the CompTIA 7-step troubleshooting methodology broken down, using your 5-part preferred explanation format. CompTIA Network plus troubleshooting methodology. Step 1, identify the problem. 1, restate the step. What's the first thing a technician should do when troubleshooting?
But we know that there's a step 0, right? Oh, log in and read. So we know there's a step 0. Step 0 is to use the OSI model as our troubleshooting guide. Okay, so that we know what layer we're in, which is also inside of identified. That's actually kind of a bad question. That question 1 was kind of bad.
An issue. 2, simplified answer. Figure out what's wrong and gather the facts. 3, analogy. It's like going to a doctor and saying, I don't feel right. The doctor starts by asking questions, checking your vitals, and noting your symptoms before even suggesting a diagnosis. 4. In-depth explanation. This step is all about understanding the situation. Gather information, logs, alerts, error messages. Talk to users. Review recent changes. Observe symptoms. Determine what's working and what isn't. This is the foundation of the process. You can't fix what you haven't defined. 5. Real-world example. A user reports, the internet is slow.
What?
You check their workstation.
This is the foundation of the process. You can't fix what you haven't defined. Based. Okay.
Ask if others are affected. Look at network activity and find high traffic to one IP. A sign of malware or misconfigured app. Now you've identified the actual problem, not just the complaint. Step 2. Establish a theory of probable cause. 1. Restate the step. What's your best initial guess at what's causing the problem? 2. Simplified answer. Come up with possible causes based on symptoms. 3. Analogy. If your car won't start, you might guess it's the battery, fuel, or ignition. You're forming educated guesses based on the evidence. 4. In-depth explanation. You list likely reasons the issue could be happening. Bad cables, incorrect IP config, software updates, firewall rules. You may reference tools like the OSI model to help narrow the possibilities. 5. Real-world example. Internet is slow. Theories. DNS resolution failure. Bandwidth hog on the network. Duplex mismatch on switch port. This step sets you up to begin narrowing things down. Step 3. Test the theory to determine cause. 1. Restate the step. How do you know your guess is right? 2. Simplified answer. Test your theory to prove or rule it out. 3. Analogy. You think your flashlight doesn't work because the batteries are dead. You test it by swapping in new batteries. If it works, your theory was correct. 4. In-depth explanation. Take practical steps to verify the cause. Run diagnostics. Replace suspected bad cables. Disable antivirus temporarily. Check port configs. If the theory is confirmed, move to the next step. If not, go back and come up with a new theory. 5. Real-world example.
What a novel concept. If you tried one thing and it didn't work, then maybe it's not that thing. Maybe go back and try to figure out a new thing that could be the new thing, the new problem. Like, that alone, if people could do that on their own, I would, like, half my job as a teacher would go away. Okay, anyway.
You suspect a firewall is blocking DNS. You temporarily disable it and DNS works again. Theory confirmed. Step 4. Establish a plan of action to resolve the problem. 1. Restate the step. What's your plan to fix the issue with minimal risk? 2. Simplified answer. Plan exactly how to fix the issue without breaking other things. 3. Analogy. Like planning surgery, you don't just start cutting. You prepare the tools, back up the system, and plan for side effects. 4. In-depth explanation. You should minimize user disruption. Document the fixed steps. Consider dependencies. Communicate with team users. Schedule changes if needed. This is especially important in live production environments. 5. Real-world example. Fix. Remove a malware-infected app and block the download domain in the firewall. Plan. Notify users. Backup data. Isolate affected systems. Then proceed. Step 5. Implement the solution or escalate. 1. Restate the step. Now that you have a plan, what do you do? 2. Simplified answer. Fix it or escalate if it's beyond your scope. 3.
Fix it or give it to somebody else who can.
Escalate if it's beyond your scope.
Oh, come on. I hate when it does that.
Excellent catch. Let's walk through this again.
No, we're not starting all the way back to the beginning.
Specifically in light of the CompTIA Network plus Study Guide's answer key. Here's your updated 5-part breakdown reflecting their preferred answer logic. 1. Restate the question. After detecting...
Okay, I don't know why it jumped all the way up there. Okay.
Absolutely. Here's the CompTIA 7-step troubleshooting methodology broken down, using your 5-part preferred explanation format.
Okay, we're not doing that. We're going here. Here we go.
Step 5. Implement the solution or escalate. 1. Restate the step. Now that you have a plan...
Analogy.
You know what's wrong with your car, but if it needs an engine rebuild and you're not qualified, you take it to a mechanic. 4. In-depth explanation. Carry out the fix if you're authorized and capable. Otherwise, escalate to the proper team or senior technician.
You know what? I'm going to start saying that from now on at work. If someone asks me to do something, I'm going to be like, you know what, man? I'm not qualified. We're just going to take that up to the next person above me. Just go ahead. Just take that issue, go on up. Go to the next dude. Yeah. Hey, you know what? Double it and give it to the next guy. That's
Provide
what we should
all
do.
your documentation so far. Avoid making the problem worse with unauthorized action. 5. Real-world example. The technician isolates and reimages a compromised PC and pushes out a patch. If the malware affected network infrastructure, they escalate to the network engineering team. Step 6. Verify full system functionality. 1. Restate the step. Did the fix work, and is everything else still working? 2. Simplified answer. Test to make sure the system is fully functional. 3. Analogy. After fixing a leak, you turn the water back on and watch closely to see if anything's dripping again. You also check nearby pipes to make sure they weren't damaged. 4. In-depth explanation. You verify. The original problem is gone. No side effects were caused. Connected systems still work. Users confirm functionality. Documentation of test results is often done at this stage. 5. Real-world example. After restoring DNS, the user's web browsing works again. You also test internal systems, shared drives, VPN access, and email to confirm nothing else was affected. Step 7. Document findings, actions, and outcomes, also known as implement preventative measures. 1. Restate the step. How do you make sure this doesn't happen again, and that others learn from it? 2. Simplified answer. Record what happened and put in safeguards. 3. Analogy. After falling on a wet floor, you mop it up and put down a caution, wet floor sign so no one else slips. 4. In-depth explanation. This step includes writing a post-mortem report, updating knowledge bases, applying patches, educating users, adjusting firewall, antivirus, ACLs, etc. It's both for future prevention and for institutional memory. 5. Real-world example. You add the malware's domain to a block list, apply endpoint protection updates across the network, and update your internal wiki with the exact resolution steps used.
Okay, so that was a little painful, but it was definitely beneficial to go through all of that. Okay, so in-depth explanation. So quick recap: the CompTIA troubleshooting methodology includes 7 official steps: identifying the problem, establishing a theory or a probable cause, confirming that theory, establishing a plan of action to resolve the problem, implement the solution or escalate to the next guy, double it and give it to the next guy. Okay. Verify full system functionality and implement preventative measures. Now, it's also very important to remember that the most important preventative measure that you could possibly do is educate the user. If the user is a boomer and doesn't understand that they actually don't have a cousin who is a prince from Nigeria or something that's going to give you millions of dollars or something, if they don't understand that, then they're going to fall victim every single time. Okay. Always be cautious when on the internet, of course. So again, identify, establish. Hey, thanks for the sub. Appreciate it. So we're going to identify the problem, establish a theory of probable cause. So this should all make sense, right? I also think about this with music, like, and if you watch any of my Tapping with Tyler videos where I've like broken down like solos and stuff, I do the same exact thing, where if there's a measure of the music that's the issue, identify the problem, right? Or more like the spot. And then I think about what's the probable cause, what's the theory. Is it the actual measure that I'm messing up on when I'm playing, or is it the measure before it, or like the line before it, or something like that? Is something else happening? Okay, then I come up with a plan of action. How am I going to practice that piece of music? What am I going to do? And usually it starts with me starting 4 measures before, making sure that those 4 measures are good before I hit the actual part. And then that's my solution. I verify that it's good and it's been implemented. Okay, we have spent way too long on this, but I feel like it was good because a lot of these questions revolved around these seven steps. So let's push forward. Just real quick, it was confirm theory and establish a plan. Okay. All right, here we go.
A help desk operator is troubleshooting a site that is no longer responsive. Which of the following is the last step the operator should perform?
Okay. So I thought it was going to be implement a solution, but it was document findings because, well, before I give my explanation, let's see what it says.
The last step in troubleshooting is to document findings. This gives you the opportunity to add a complete description of the problem and its solution, including findings, actions, and outcomes.
Does it say that in here? Steps include writing a post-mortem report right there. Okay, so this is also another reason why I went through this, to make sure that we understood what was going on. Okay, so that makes total sense. And notice that, like, I took time to make sure I understood the core concept of what was going on. I don't feel like I need to put this in ChatbotGPT. Like, that's kind of a waste of time. I will read the rest of this all at once, just to make sure that I fully understand where the other things fall. But very clearly it makes sense to me now that it's documenting.
The last step in troubleshooting is to document findings. This gives you the opportunity to add a complete description of the problem and its solution, including findings, actions, and outcomes. Implement the solution or escalate as necessary occurs before verification. The technician has to apply the solution first, or there would not be much point in verifying. Testing the theory to determine the cause occurs after establishing the theory. Once confirming the theory, determine the next steps to resolve the problem. If the theory is not confirmed, then re-establish a new theory or escalate. This step is not the final step in the process. After determining the cause, the operator should establish a plan of action to resolve the problem and identify potential effects. This is not the final step in the process.
Okay, and this makes total sense, because after you've gotten everything correct, you need to write it down for the next guy to know, because you might not be the technician that works on this stuff. I should do that for the... Oh, I already read that, chat. Cool, let's move on to the next one. 4 out of 8, let's go.
When following standard troubleshooting guidelines, an IT support technician asks a user, did it ever work? And when did it last work? These questions help with which of the following troubleshooting approaches when identifying the problem.
Okay, so I thought it was documenting findings and actions, because it sounds like they're trying to gather information, but in reality, it's determining if anything has changed. Because we've done the work beforehand, it makes total sense why that is. Let's read and make sure where the other ones lie.
Determining if anything has changed can help pinpoint a cause of failure. For example, if a system has experienced problems after a software update, the update is suspect. Establishing a theory of probable cause includes questioning the obvious. The process of elimination of causes and determining the difference between what should happen and what actually happens is helpful. Testing a theory would include an action such as replacing a suspected bad cable with a good one. Tracking systems, such as a ticketing system, record who is responsible for any given problem and what its status is. This includes a complete description of the problem and its solution, findings, actions, and outcomes.
Yeah, the ticketing system. This is why it's so important for you to make help tickets, like for like IT and stuff. I know it's a pain in the butt to do it, but the reason they have that do it for two reasons. One, that's how those technicians get paid, because they have physical evidence and proof that they did what needed to get done. And then two, it stays in the system and it starts building this library of troubleshooting, so that way they can troubleshoot issues even faster. Yeah. Okay, so again, what's going on is that the standard troubleshooting method, the guy asked, did it ever work? And when was the last time it worked? He's trying to determine if anything has changed. Documenting findings, actions, and outcomes would be after. This would be following that report that we just did in the last question. Documenting findings. Okay. This one's a little bit different. Let's see what's going on.
Physical server has been plugged in, powered on, and networked into the communication closet. Using a KVM key video mouse device, the network technician notices there is no network connectivity. Examining the back of the server, the LED status indicators for the port are off. After identifying the issue, establishing a theory of probable cause, and testing the theory, which course of action should the network technician take next?
Okay, so if the LED lights are off, that means either the port is down, or it's a bad wire, or it's not getting electricity. And the port could either be down or it could just be off. So let's see here. So the correct answer was step 1, establish a plan. Step 2, implement a solution. Step 3, verify network connectivity. Okay, I thought it might have been verify system functionality, but we don't need to do that because it's already off. We already know that the light is off. Okay, step 2, implement a solution. Step 3, document outcomes. Let's see what's going on. Why is this one correct?
When establishing a plan of action to resolve the problem, implementing those steps follows in the course of action. The technician can then verify the network connectivity to confirm the solution worked. After testing a theory of probable cause, implementation of a solution does not occur afterward. Documentation of the outcome also cannot happen until network connectivity is confirmed to be working. Documentation of findings, actions, and outcomes does not occur before establishing a plan. Documentation happens at the end of the troubleshooting process. Verifying system functionality does not occur before implementing a solution. It happens afterward.
Okay, so I'm not gonna lie, this question is kind of crappy. Like, it's kind of underhanded. It's underhanded for a few reasons. One, it's giving a scenario and it's explaining the back of the server, the LED lights indicators are off. So it's already establishing and telling you what the problem is, and that you as the technician, you already know what this is, but it does a really bad job of explaining that, of what's going on. It's kind of like implied. Okay. Second is that all the answer choices are step 1, 2, and 3, which contradict. Like, the fact that it says step 1 has nothing to do with the fact of, like, step 1 is identifying the problem. Like, these are just step 1, 2, 3 in terms of what your next actions are. And that can be very misleading. And I hate when tests do stuff like that. So, and I'm not gonna lie, it kind of got me too, because I was still like a little shaky. I couldn't quite remember the 7-step method. Okay. So the first one is we're not going to document findings because, so when it comes to questions like this, we just need to ignore step 1, 2, and 3. Just think of it as bullet points. That always helps me. And the chronological order that it's being said in is the chronological order that should be happening next. Okay. So determine the findings. Okay. That is the very last thing. Our documenting findings. That's the very last thing. So that one's done. Okay. Test the theory. Well, we don't have a theory yet. All we've done so far is that we have identified what the problem is. I have theories. I think the port might be down. I think it might be a bad cable. So establish a plan, implement a solution, and verify the thing. Verify the connectivity. Now, I do think. Oh, here we go. So after identifying the issue, yes, which we have. Establishing a theory of probable cause and testing the theory. So it's already telling you where you are in these steps. So if I would have just kept reading, it says the next steps have already been taken. So it just makes sense that the next spot is going to, I know what the problem is. I've identified it. I have a theory of probable cause now, and I've tested the theory. And it seems like that's what it is. So now I need a plan of implementation of doing it. I need a plan of doing it. Okay. So then after I've done it, or after I have the plan, I'm going to implement it. And then I'm going to verify that the connectivity works. After I verify the connectivity works, I'm actually going to then document my findings. Okay. So this makes total sense. We're going to move on. All right, this one, I'm good, but we're going to
When changing a system as part of implementing a troubleshooting solution, which of the following practices should be followed? Select 2.
Okay, so when changing a system as part of implementing a troubleshooting solution, which of the following should be true or should be followed? Recording all changes made during the troubleshooting process. Okay, that's important. That goes back to the documentation. Okay, we always need documentation. If it's an issue that is constantly happening, especially if it's a big issue, if you document down the troubleshooting that you did and say that it did not work, the next technician is going to see that, and it's going to save a lot of time. Make changes without backing up data. That's just ridiculous. You never make changes without backing up data. Test after each change to ensure the problem is resolved. That also makes total sense. If you change one factor of a thing, you need to then test to ensure that the problem was resolved. The problem was not resolved, therefore that can't be the thing. Okay, that cannot be the solution. Implement all suggested solutions all at once. I want you to name me one moment in your entire life where doing everything all at once at the same exact time ever went well. When has that ever happened for anyone in the history of the world? Never. Like, never. It has never happened. It never will happen. Like, doing something at one thing at a time is always going to be good. The best outcome. Now, don't get confused. A difficult thing is only a conglomerate of really simple things that are all on top of each other. Not happening all at once, sometimes, but it's more of like it's all a bunch of simple things that are happening that you have to do. You know, like you're going to go ride your bike. Okay, you have to walk to the bike. You have to balance on the bike. You have to pedal. Like all these things are very simple, but then you stack them on top of each other. It makes something that's very difficult. Okay, we're not going to have it read all of the stuff, but we are going to have it read this. Just
The following are the practices you should follow. Test after each change to ensure the problem is resolved. Testing after each change is crucial in troubleshooting to verify that the solution has effectively resolved the problem without introducing new issues. It allows for a systematic approach to identifying the root cause and confirming the effectiveness of the solution. Record all changes made during the troubleshooting process. Keeping a record of all changes made during troubleshooting is essential for several reasons. It helps in understanding what has been tried, aids in the rollback process if a change worsens the situation, and contributes to knowledge sharing and documentation for future reference.
Good. Now, I also want you to think about this too, as we move on to the next one. Just because something is simple, if you've never thought it through, then it doesn't matter how simple it is, it's gonna get you. Like, you need to always think through everything. Like, it does not matter how simple it is. Some of the easiest drum music has gotten me, and I've messed up on it because I didn't give it the time to think it through. Now, it might not need like hours to think through, but you should always think through everything regardless of how simple it is, because that's how scams work. Scams are very simple. Phishing is very simple, and people think that they're smarter than they actually are, and they've never actually exercised their problem-solving skills. And because they've never actually exercised it before, they get it all confused, and they don't know the steps, and they don't know which one should happen first, and they put them in different orders, and then boom, bam, you lose $1 million, and you're on the street, and you're under a bridge, and you're begging for things, and you're eating a shoe. Like, it doesn't matter how simple something is, it always requires the same process. Okay, good. All right, let's see what's going on with this thing. The troubleshooting network issues. What is the first step in resolving it? Very simple. It is identifying the problem. So let's see if we can put these in order without checking it first. So identifying the problem is number one. We can't establish a plan yet. Establishing a theory and probable cause is going to be number two. Testing the theory to see if it works is going to be number three. And then establishing a plan of action and resolve is going to be number four. And if we go back here, identifying the problem, number one, establishing a theory, number two, testing the theory is number three, and establishing a plan is number four. If we go beyond that, we're implementing the solution, verifying that it works, and then documenting our findings. So in all reality, like, it makes total sense. And the more you do it, the more it's one of those things you just kind of sit there and you're like, duh, like, why do I need that? Okay, we're gonna move on. Oh, and if anybody wants me to like go more in depth, or like have it read, or me read, or like whatever this is down here, just say so, and I'll fix it. I'll put chat. Chat will be on top. I forgot my camera is kind of covering up chat, so no one can see it. All right, let's see what's going on with this.
A technician tries the suggested troubleshooting steps to remedy a computer issue. The steps do not fix the problem. The technician discovers additional suggestions at a support website that provide a different cause and potential fix for the problem. What troubleshooting path should the technician follow?
Okay, so this is exactly what happened with the remote, the Xbox remote that I had. There was an issue, wasn't connecting to my girl's computer. I thought the issue was the controller. It was not the controller. I then came over here and I tested it out, and it worked totally fine. So therefore, the issue must have been somewhere over there. Now, if she has issues with it, because I haven't tested it yet, if she has issues with it, what do you think the issue is? Probably the driver for the NIC, maybe the driver for the controller. something's not updated, or I'll go to the forum. So, because very clearly something's messed up. So, if the theory is not confirmed, reestablish a new theory and or escalate. So, we don't want to duplicate the problem. That's not a bad thing, but it's not necessarily what we want to do. Document findings, that's the last thing that we do. Establish a plan of action to resolve the problem and identify potential effects. No, because we don't really have a plan. It says that it didn't work. The technician discovers additional suggestions because his steps did not fix the problem. So it's still going on. So let's see what's going on. Let's read this real quick. Let's read the very top one.
Often problems may have several different possible causes. When a theory is not confirmed, the next in line can be considered. Escalation means referring the problem to a more knowledgeable entity such as a senior technician, manager, or third party.
Okay, whenever you have a problem, doesn't matter if it's this or whatever, whenever you have a problem, it's always best to pull yourself out of it and make it as simple as possible. Here's the thing. Here's the question. There's an issue. He tried a thing. The thing did not work. Therefore, he's going to make a new thing. Reestablish the new thing. And or double it and give it to the next guy. Alright. I feel armed with knowledge. Let's
A
go.
help desk operator is troubleshooting a site that is no longer responsive. Which of the following is the last step the operator should perform?
Documenting his findings.
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
Oh, I was not paying attention. When considering a troubleshooting methodology, which of the following topics concern identifying the problem? Questions and observation, duplicating the problem if possible, identifying the symptom, gathering information. Duplicating the problem if possible. I don't know where that fits in, but it's definitely... Which of the following topics concern identifying the problem? Make it simple, Tyler. Don't go crazy with it. Okay? I'm sure. What? When considering troubleshooting methodology, which of the following topics concern identifying a problem? I swear to God, if it's duplicating the problem, questions and which of the following topics concern identifying? I bet you anything it's not gathering information. All right.
A user contacts support to report that their computer is running slowly and they cannot access the company's internal website. What is the most effective troubleshooting strategy to identify the issues?
See what we got.
Implement the solution or escalate as necessary. Establish a theory of probable cause. Approach multiple problems individually. Divide and conquer.
Okay, so remember I said like you're gonna have one that's throwaway. The divide and conquer. That one's gone. Get out. Get out of here. Okay. Approach multiple problems individually. I'm gonna say establish a theory and a probable cause. So the user contacts support and reports that a computer is running slow and cannot access the company's internal website. What is the most effective troubleshooting strategy to identify this issue? We can't implement a solution because we don't have a theory yet. Approach multiple problems individually. I think that's also a throwaway. I'll be really upset if this is wrong. I'm really upset. What is the most effective troubleshooting strategy to identify the issue? Approach multiple problems individually? How is that anywhere in this system? Okay, we're gonna keep going.
A new physical server has been deployed and is connected to a client switch. While logged into the server via a KVM key video mouse device, the network admin notices that the network port is not connected. In addition, the switch configurations have disabled all unused ports. After establishing a theory of probable cause and testing the theory, which course of action should the network admin take next?
Okay, so we've already tested the theory. We've already talked about this one ad nauseum. After establishing a theory and probable cause and testing the theory, the next thing is to establish a plan, implement a solution, verify the network connectivity.
When troubleshooting a hardware malfunction, which of the following strategies would assist in accurately identifying the root cause affecting a device's performance?
I feel like I had this question. When troubleshooting a hardware malfunction, which of the following strategies would assist in accurately identifying the root cause affecting a device performance? Implementing a solution. We need to select two. Okay, I'm gonna say duplicating the problem because it's a hardware and that's easy to do. So when troubleshooting hardware, which of the following strategies would assist in accurately identifying the root cause affecting a device's performance? We can't implement a solution. Questioning use isn't gonna do it. So determine the next steps to resolve. I'm gonna say I'm sure. I swear to God, if it's questioning users, your boy's not doing good.
A technician tries to duplicate a reported problem on a user's computer. Which of the following troubleshooting steps is the technician focusing on?
Technician is tries to duplicate a reported problem. Where is duplicating a problem in this method? I don't remember hearing that literally anywhere. It's nowhere, dog. Where is duplicating the problem in this 7-step method? Is that in testing? Testing a theory? Okay. Anyway, I'm gonna say I don't know yet. So that way I can go over it. To fully solve a problem, what proactive step should be taken? Tell me.
Avoid communicating the solution to the customer.
Yes.
Ignore any factors that may cause the problem to recur. Try to eliminate any factors that may cause the problem to recur. Increase the complexity of the system to prevent easy access.
Okay. Throwaway answer. Avoid communicating the solution to the customer. We don't want the customer to know how to fix their own things. Imagine a world where people actually knew how to fix their phones. Everybody would be out of a job. There would be nobody, right? Like we want to gate this information. No one should know how this works except for us. Okay, I'm kidding, of course. Okay, ignore any factors that may have caused the problem to occur. No, like again, that's stupid. So we want to try to eliminate any factors that may cause the problem to recur. We don't want to increase the complexity of the system to prevent early access or easy access. No. I'd love if my phone was fixable. Spoken like a true iPhone user. Actually, all phones are awful to repair now. When I was in college, I used to repair phones, but that was back right when Android started making their phones be like, it was like a sandwich. It had their back plate, like their motherboard, and then the screen, and it was like all together. So like replacing the screen on those things were awful. Replacing screens on iPhones was incredibly easy up until like the iPhone like 8 or 9 or something like that. The battery is messed up. Ooh, look, if it swells, it's not good. All right, let's see what's going on with this.
A newly deployed stack with servers, network switches, a KVM key, video, mouse, storage unit, and uninterruptible power supplies has just been fully cabled. After powering on the stack, there seems to be a network connectivity issue between the switch and servers. What is the best approach when trying to resolve this type of network issue?
Okay. there's obviously way more to this problem-solving method that goes way more in depth, because my first inclination is that if it's the problem with the switch to the servers, then it's probably a bottom to top issue. But at the same time, if you just deployed a newly deployed stack with server networks, like, that's a lot. So I would think also to divide and conquer. But this divide and conquer has come up a lot. I don't know what it means. So we're just gonna submit. It's not spelling, but working on replacing it, which has been a whole thing because of the service provider. Imagine. Okay. Duplicate the problem if possible. Okay. Here we go. Read me the...
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
I hate when that happens. Whoa. No, ChatbotGPT froze. Where's your god now? Okay. I forgot that I had Nightbot. I need to get back in there. I used to have like riddle of the day and like quote of the day and stuff like that. Okay, I am very interested. What does it have to say?
It is important to take enough time to determine what caused the problem so that a recurrence can be avoided. Gathering information is an important first step in identifying the problem. When troubleshooting an issue, it is important to identify symptoms. Doing so goes hand in hand with gathering information to identify the problem. If possible, duplicating the problem is helpful when gathering information about the issue. This includes trying to take the same steps as the user. Establishing a theory of probable cause occurs after the problem has been identified. During this troubleshooting step, questioning the obvious is a popular approach. Process of elimination of causes and determining the difference between what should happen and what actually happens is helpful.
Question. Yes. Okay. See? ChatbotGPT thought the same thing. Let's see what it has to say. Do the thing.
Perfect. Let's break this question down using your 5-part method, especially since it's a select 3 type. 1. Restate the question. When applying a troubleshooting methodology, which 3 actions are part of the identify the problem step? 2. Simplified answer. Question the obvious, identify symptoms, gather information. 3. Analogy. Imagine you're a mechanic and someone says, my car isn't working.
Nice, good for you.
You ask obvious questions. Did you put gas in it? You identify symptoms. Does it crank? Does it make noise? You gather information. When did this start? Any recent repairs? Before you fix anything, you have to fully understand what's going on. That's what these steps help you do. 4. In-depth explanation. In the first step of the CompTIA troubleshooting methodology, identify the problem. The goal is to collect all the details that define the issue. Here's how...
See, that's what I thought. And you do that by question the obvious. Oh. Question the obvious. I thought it... I'm dyslexic. I read question and observe. Damn it. Well, now that makes total sense why it's not that. So then why does ChatbotGPT think that? Let's keep
how
going.
Each correct choice fits. Question the obvious. Ask basic common sense questions. Example, is the cable plugged in?
Okay,
Is the
that makes
device
sense.
powered on? This catches the simple stuff that's often overlooked. Identify symptoms. Differentiate between user reports and actual technical symptoms. For example, the internet is down might mean DNS is failing, not actual connectivity.
What's going on?
Gather information. Collect logs, screenshots, recent changes, user input, and observed behavior. It's about building a clear picture of the environment and the issue. Duplicate the problem if possible. This is not part of step 1. It belongs in step 3, test the theory to determine cause. You only attempt to replicate the issue after forming a theory about what's causing it. 5.
So that's where duplicate goes. Duplicate goes in step 3, testing the theory. And that makes sense. You're testing the theory because if you think you know why something's working or why something is happening, why this problem is happening, you go and you test it out to see if you can recreate it. If you can recreate the issue, chances are you'll be able to fix it. Okay. Now, I also think, because there's been tons of times where I'm troubleshooting things and I ask the person I'm helping to replicate the issue. So, because if I can see her replicate or them replicate the issue, chances are I'm gonna be able to fix it, or I'm gonna be able to fix it faster.
5. Real world example or scenario. A user reports they can't access a shared drive. You question the obvious. Is the network cable connected? You identify symptoms. They can browse the web but not reach the internal file server. You gather information. Recent updates were pushed to the network, and their drive mapping was altered. Together, these actions help define the scope and start guiding your diagnosis.
Okay. So, when considering a troubleshooting methodology, which of the following topics concern identifying a problem? So it's saying that duplicating the problem can help. Well, I would say duplicating the problem can do both. I would say that it can help identify the problem. Like I said earlier, if you replicate the issue, I will be able to identify the problem. But it also shows that your theory worked. If I think that the Xbox remote, my theory is that it's the Xbox remote. I'm going to try to duplicate the problem again on my computer. I was not able to duplicate the problem again. Therefore, my theory is wrong. You know? So let's see what it says.
Great follow-up. And you're absolutely right to go with the official CompTIA Network Plus study guide as the source of truth for the exam. Let's now go through it again using your 5-part method with the correct CompTIA approved answers. 1. Restate the question. When applying the troubleshooting methodology, which 3 actions are part of the identify the problem step? 2. Simplified answer per CompTIA. Duplicate the problem. If possible, identify symptoms, gather information. 3. Analogy. Let's say a customer reports their coffee maker is broken. You ask them to show you, duplicating the issue. You observe what happens. Maybe it won't brew or the light won't turn on. You gather more info, like when it started, whether there was a power surge, or if others had the same issue. These actions give you a full picture of the problem before deciding what to fix. 4. In-depth explanation. In the Identify the Problem step, CompTIA outlines several best practices. Duplicate the problem if possible. If safe to do so, try to reproduce the issue. This helps verify that the problem is real and not user error or a one-off glitch. It also gives you direct visibility into the behavior. Identify symptoms. Observe and define the specific symptoms, what the system is doing, what errors appear, what fails, and what works. Distinguish facts from user opinions or vague complaints. Gather information. This includes asking users, checking logs, reviewing recent changes, understanding the environment. Together, these provide context for the issue and help steer you toward an accurate theory. Question the obvious. Although this is a useful mindset, it's not listed by CompTIA as one of the core actions under Identify the Problem in their
And there it is. Although this is a useful mindset, it is not listed by CompTIA as one of the core actions under the Identify the Problem. Okay.
methodology. It may still be used in practice, but for exam purposes, it's not one of the 3 to choose here. 5. Real-world example or scenario. A user says, the printer is broken. You walk over and try to print yourself, duplicating the problem.
Okay.
You notice the error message says paper jam, identifying symptoms. You ask when it started, check the logs, and learn someone used the wrong paper type this morning, gathering information. Now you're ready to move to the next step in the troubleshooting process. Thanks for the correction. Your attention to the exact...
Okay, and then questioning the obvious would be like, is it plugged in? Does it have paper? You know? But that... I think I might understand why that's not a part of the thing, because if I walk over and I duplicate the problem, it's going to fit, like, it's going to answer those obvious questions. If I walk over to the printer and I can't print myself and I see the error message of no paper, or I can't even hit the on button, it's very obvious. And I'm not kidding. I've legitimately had people come to me say, like, Tyler, I need help with my laptop. It just will not turn on. I do not understand. And it's because they didn't realize on their Chromebook, the on button was on the side and not on top. They legitimately did not know where the on button. So they actually didn't know how to turn it on. So just how those things go. Okay. So we'll just restate the question real quick.
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
So we're going to duplicate the problem if possible. We're going to identify the symptoms, and we're going to gather information. Got it. Ooh, this was the one I was mad about.
A user contacts support to report that their computer is running slowly and they cannot access the company's internal website. What is the most effective troubleshooting strategy to identify the issues?
Okay, it says approach multiple problems individually. I didn't know that was a part of the method. Next question. All right. And then we'll get rid of this stuff. We don't need this. We don't need this. We don't need this. We don't need that. Ooh, I need to see if I'm teaching lessons today. All right, let's see what it says while we let ChatGPT.
Discovering symptoms of more than one problem is common. When problems do not seem to be related, it is best to treat each issue as a separate case. In a divide and conquer approach, rather than starting at the top or bottom of the OSI reference model, a start is initiated with the layer most likely to be causing the problem. Establishing a theory of probable cause includes questioning the obvious. The process of elimination of causes and determining the difference between what should happen.
Okay, you can't tell me that that's not a part of the method and then go in there and tell me that's part of the method. Not after I just rationalized it. Okay. Establishing a theory of probable cause includes questioning the obvious. Okay.
And what actually happens is helpful. Escalation means referring the problem to a more knowledgeable entity such as a senior technician, manager, or third party if a solution has not been found or proven to not work.
Okay, discovering a symptom. What is this again?
Discovering symptoms of more than one problem is common. When problems do not seem to be related, it is best to treat each issue as a separate case.
Okay. A user contacts support to report that their computer is running slow. And because they have two different issues. Their computer is running slow and they cannot access internal website. I wrote that off as one thing. That is two separate things. So then it makes sense why you would approach multiple problems individually. They might be connected, but that's neither here nor there. All right, do the thing.
Excellent. This question is about choosing the most effective troubleshooting strategy when faced with more than one user-reported issue. Let's break it down using your 5-part method. 1. Restate the question. A user reports that their computer is slow and they can't access the internal website. What is the best troubleshooting strategy to figure out what's wrong? 2. Simplified answer. Approach multiple problems individually. 3. Analogy. If a car won't start and also has a flat tire, you don't try to fix both at once. You look at the engine issue first, then the tire. By handling one issue at a time, you avoid confusion and can solve both more effectively. 4. In-depth explanation. When a user reports more than one symptom, in this case, a slow computer and internal website access issues, it's possible they're related, for example, DNS failure or malware, or they're completely separate, for example, local system slowness, plus a network issue. The best strategy is to treat each problem independently at first. Check system resources for slowness. Test internal network or DNS access separately. This keeps troubleshooting focused and logical, avoiding confusion caused by overlapping symptoms. Let's briefly rule out the incorrect answers. Implement the solution or escalate as necessary. That's step 5, which comes after diagnosis, not as a method of identifying the issue. Establish a theory of probable cause. That's a valid step, but not a strategy for handling multiple issues. It assumes you're already focused on one problem. Divide and conquer, a tempting choice, but in CompTIA terms, this usually refers to isolating a system or function, like testing one section of a network, not analyzing multiple problems. It's also not the best strategy for handling multiple symptoms from the start. 5. Real-world example or scenario. A user says their PC is sluggish and they can't reach the intranet portal. You check Task Manager and see high CPU usage due to a background update. That's one issue. Separately, you ping the internal site and find the DNS server is unreachable. That's the second. By approaching these individually, you uncover two separate causes and avoid getting misled into thinking it's one big, complex problem. Let me know if you want a comparison of divide and conquer versus...
Yes, I actually do want that. Okay. Users slowly, they cannot access company internet. What is the most effective troubleshooting strategy to identify the issue? Approach multiple problems individually. Okay, this makes sense. I understand what's going on with it. I want to make sure that I understand this.
Absolutely. Here's a full comparison of divide and conquer versus approach multiple problems individually using your 5-to-part format. Compare divide and conquer versus approach multiple problems individually. 1. Restate the comparison question. What's the difference between the troubleshooting strategies divide and conquer and approach multiple problems individually? When should each one be used? 2. Simplified answer. Divide and conquer. Break one large problem into smaller parts to isolate the root cause. Approach multiple problems individually. When facing more than one issue, treat each as a separate problem until proven related. 3. Analogy. Divide and conquer. You're looking for a leak in a long pipe. Instead of tearing up the whole thing, you test section by section until you find the leak. Approach multiple problems individually. A homeowner calls about both a leaky roof and a broken dishwasher. You don't assume they're connected. You inspect the roof separately from the dishwasher. 4. In-depth explanation. Divide and conquer. This is used when you're troubleshooting a single complex issue, for example, the network is down. You split the system into logical chunks, layers, segments, systems. Example, troubleshooting internet access by checking from the local computer, then the switch, then the router, then ISP. When to use. One big problem with unknown origin. You want to isolate where in the process the failure occurs. Approach multiple problems individually. Used when a user reports multiple unrelated symptoms. Instead of assuming they're part of the same root cause, you treat each one as a standalone issue. This prevents false correlations. When to use. Multiple issues, for example, my computer is slow and I can't print. You want to avoid wasting time by assuming there's one fix for everything. 5. Real-world example or scenario. Divide and conquer. A user says, I can't get to the internet. You test. Can they access their local network? Can they reach the default gateway? Can they ping external IPs? You isolate where the connection fails. That's divide and conquer. Approach multiple problems individually. A user says, my Wi-Fi drops randomly and my email won't sync. You first check the Wi-Fi signal strength, drivers and router logs. Then separately check email credentials, mail server status, and application logs. Turns out, Wi-Fi issue was interference. Email issue was due to password expiration. Totally separate problems. Solved faster by treating them separately. Would you like to continue with the next question in section 5.1?
Okay. That was really, really long, but that was really, really good. I feel like I got a lot of information with that. Let's continue onward. All right. I think I was also upset with this. I usually am upset
when troubleshooting a hardware malfunction, which of the following strategies would assist in accurately identifying the root cause affecting a device's performance?
Question. It seems so simple now. It seems so simple. Of course, I'm going to duplicate the problem, and I'm going to question the user. Determine the next steps to... Like, why did I click that? I feel like that's very obvious.
Questioning users is one way to identify a hardware problem. The first report of a problem will typically come from a user or another technician. Duplicating the problem, especially on the user who reported it if applicable, will further pinpoint the exact problem and confirm reports of the issue to the troubleshooter.
Ah, see, I was right. Bottom, top. Divide and conquer. So now I put divide and conquer because I didn't understand what it is. I think I kind of understand like the difference between divide and conquer and approach problems individually. Hold on. Let me read this again.
Divide and conquer. Break one large problem into smaller parts to isolate the root cause. Approach multiple problems individually. When facing more than one issue, treat each as a separate problem until proven related.
So one has one large problem that then gets broken down into smaller things. One is a bunch of problems that you assume are not connected, so you treat them as separate until you have other information. Okay.
A newly deployed stack with servers, network switches, a KVM key, video, mouse, storage unit, and uninterruptible power supplies has just been fully cabled. After powering on the stack, there seems to be a network connectivity issue between the switch and servers. What is the best approach when trying to resolve this type of network issue?
So then it would be a bottom up. Let's see if this suffices what I want it to tell me. I want to make sure that I understand what bottom up is, bottom to up, top, because there's like this hierarchy, like the servers, the routers, the switches, the devices, like it's like this tree.
A bottom-to-top approach of the OSI Open System Interconnection model is a methodical validation of network components starting from the bottom or layer 1 physical and going up. This is most appropriate because cables have just been connected. A top-to-bottom approach of the OSI model is a methodical validation of network components starting from the top or layer 7 application and going down. Systems are at default, so basic network connectivity should be available. Divide and conquer approach starts with the layer most likely to be causing the problem, then work either down or up depending on the test results. A plan of action occurs after a theory has been tested and a cause of the issue is determined.
Okay, that makes sense. That makes sense. Let's continue.
A technician tries to duplicate a reported problem on a user's computer. Which of the following troubleshooting steps is the technician focusing on?
Well, now I understand that duplicating a problem is a part of step 1, which is problem identification, which is what we had right here, identifying the problem. So that's why sometimes it's important when you're like doing this stuff to go down the rabbit hole in ChatGPT, learn like the 80-20 principle, like learn more than what you think you do, or learn until you don't have a question about that subject anymore, about that topic. Like just keep going, keep asking questions, just go down the rabbit hole. And after you get even 1 or 2 layers deep into that, when you come back to the actual question, it's elementary. It's rudimentary. You know what I mean?
It is important to take enough time to determine what has caused a problem. Identifying the problem includes a variety of steps that help to understand what is and is not working. This includes interviewing users and identifying symptoms for a diagnosis.
Okay, so the technician tries to duplicate the problem, which is problem solving, or which is the problem identification. Which of the following? Good. Let's keep going. All right, chat. This is it. There's only 2 questions that we have not gone over, so we should be able to run through these.
Which of the following troubleshooting steps includes open and closed approaches to obtaining information?
Okay, remember how I said there was 2 questions that we still haven't gone over yet? This is one of them. Okay, which of the following troubleshooting steps includes open and closed approaches to obtain information? Documenting findings, that's the last one. Open and closed approaches. Questioning users, questioning the obvious. Test the theory to determine. I'm going to say that I think that it's test the theory to determine. It makes the most sense, right? Because what's tripping me up is that it says includes open and closed approaches. I don't know what open and closed approaches are, meaning that you're trying something and then you're not trying something. I was wrong. Fantastic. Let's move on.
A user calls to report that email is not working and that there is a printer jam. Which troubleshooting approach is best when identifying the problem?
Divide and conquer, because no, divide and conquer is one problem that you break down into multiple things. Approach multiple problems individually. They probably are not connected. They might be, but they're probably not. Establish a theory. The theory is that the problem's between the keyboard and the chair. Implement a solution, escalate, double a problem, take it to the next guy. All right.
A technician tries to duplicate a reported problem on a user's computer. Which of the following troubleshooting steps is the technician focusing on?
Okay, we now know that that's a problem identification.
When identifying a network problem, which of the following would help pinpoint or isolate the actual issue a user, system, or organization may be experiencing?
So we're okay. Keyword: identifying a network problem. We're identifying. Okay, so we're not determining next steps to resolve. We're not implementing a solution. We are trying to duplicate the problem, and we're questioning users. Let's go.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future?
Okay, we're trying
Select 2.
We're trying to mitigate in the future. Okay, this I remember this because. Okay, hold on. What should the sysadmin do to help mitigate this in the future? Establish a plan of action to resolve the problem. We want to implement preventative measures for sure. Just don't know. Let's think. Sysadmin is reviewing an alert for a firewall that a piece of malware was downloaded. Oh, we need to confirm the theory because the alert could be wrong. It could be a false flag. I remember this. Okay, I'm sure. What? Okay. Damn it.
A user is unable to print to a network printer. Which of the following is the first step that a technician should take to troubleshoot the issue?
Identify the problem. We don't want to, because this is asking about steps. That's step 1, establishing a plan. The theory is 2. This is actually 5, and that's 6.
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
Identifying symptoms, duplicating the problem if possible, gathering information. Questioning the obvious is actually duplicating the problem.
A system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with application support personnel. In which of the following ways should IT troubleshoot the matter? Verify full system functionality and, if applicable, implement preventive measures. Determine if anything has changed. Establish a plan of action to resolve the problem and identify potential effects. Identify the problem.
Okay, so a system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with the application support panel. In which of the following ways should IT troubleshoot the matter? By establishing an action plan to resolve the problem and identify potential effects. I'm gonna say that's it. Determine if anything has changed. That doesn't make sense, because in which of the following ways should IT troubleshoot the matter? Determining if anything changed. I mean, maybe if you implement the thing. I'm going for it. I was right. All right. Is this the one that I was mad at? Probably.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
Establish a plan of action to resolve the problem. I think this is a dirty question because this makes me think that it's preventative. Or no, not preventative, that it's like action. Like, this is what I'm doing. I have a plan, I'm gonna execute it to resolve the problem. When in reality, it's preventative. Interesting. Let's see what it says.
Since the administrator suspects they know what the issue is, following the basic network troubleshooting steps, the next step is for the administrator to confirm the theory. After confirming the theory, the next step the administrator would take is to establish a plan of action to resolve the problem.
Okay. To mitigate this in the future. This makes it sound like it's super preventative, but I think what it really wants to know is like, what's he gonna do next? It was downloaded onto the computer of the network. What steps should the sysadmin do to help mitigate this in the future? To confirm the theory, to like basically like, how is he gonna solve this later? Okay. Establish a plan of action to resolve the problem. Confirm the theory. Okay.
Which of the following troubleshooting steps includes open and closed approaches to obtaining information?
Question users. I feel like I got this wrong twice.
Questioning users is a good first step to help identify a problem. 2 types of questions can be asked. Open-ended questions invite a descriptive response, whereas closed-ended questions result in a yes-no response.
That's what it meant by open-closed approach. I didn't understand that. Now I do. So open-ended question, closed-ended questions. Okay. I have to pee.
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
And I was right. I was right. Gathering information, duplicating the problem if possible, and identifying systems. Symptoms. Question the obvious. That is not a thing. Excellent. This is the last one. I was right with this one too. Let's go.
A system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with application support personnel. In which of the following ways should IT troubleshoot the matter?
Establish a plan of action to resolve the problem and identify potential effects. Because nothing else makes sense. Determine if anything was changed. That doesn't necessarily apply. A system contains custom application. So we already know what the problem is. Okay. It decides to upgrade. We decide to upgrade the OS support panel. In which of the following ways should IT troubleshoot this matter? Okay. Let's keep going. We should be able to go through, just blow through this, boys.
When troubleshooting a hardware malfunction, which of the following strategies would assist in accurately identifying the root cause affecting a device's performance?
Hardware malfunction. So we're going to question the user. We're going to duplicate the problem. Implement a solution. We don't know. We don't know what the problem is yet. Okay. Determine the next step. We don't know that yet either. We got to. Yeah.
When changing a system as part of implementing a troubleshooting solution, which of the following practices should be followed?
When changing a system as part of implementing a troubleshooting solution, which of the following practices should be followed? Select 2. Record all changes made during the troubleshooting process. Make changes without backing up. Oh no, that's bad. Test after each change to ensure the problem is resolved. Implement all suggested solutions all at once. Okay, I've already had this question. We're good.
A user contacts support to report that their computer is running slowly and they cannot access the company's internal
Two
website.
problems.
What is the most effective troubleshooting strategy to identify the
multiple
issues?
problems individually. Assume that they're not connected, even though they might be, but you'll figure that out later.
A technician is troubleshooting an issue with an employee's computer after a recent update. The technician asks the employee questions such as, "Has this setup worked properly before?" And "When was the last time it worked as expected?" These questions help with which of the following troubleshooting approaches in pinpointing the issue.
You fool!
Really, really.
He gave me extra. I got another vase for you. Just for
Thanks, babe. You took a bite out of my kolache.
No, that was the guy. I think that's why he gave me the donut.
Okay. Okay. Anyway, that's good. I'm falling asleep. I had to go pick her up at the airport at like 12:30 last night.
A technician is troubleshooting an issue with an employee's computer after a recent update. The technician asks the employee questions such as, "Has this setup worked properly before?" And "When was the last time it worked as expected?" These questions help with which of the following troubleshooting approaches in pinpointing the issue.
Okay, so we're determining if anything's changed. Testing the theory. No, we're establishing a theory of probable cause. What? We're determining if anything changed? I got it wrong. That's what happened.
Fucking shit! Don't fucking do that! Fuck!
She mad. Has this setup worked properly before? When was the last time it worked? Determining if anything has changed. I swear to God, if that's not the right answer either.
A newly deployed stack with servers, network switches, a KVM key, video, mouse, storage unit, and uninterruptible power supplies has just been fully cabled. After powering on the stack, there seems to be a network connectivity issue between the switch and servers. What is the best approach when trying to resolve this type of network issue? A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
We are going to establish a plan of action to resolve the problem. Implement preventative measures. I feel like I've gotten this wrong 3 times.
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
We need 3.
When considering a troubleshooting methodology, which of the following topics concern identifying a problem?
Good, now I got chocolate on my hand. Okay. I remember I had read this wrong. I'm trying to remember. Because this is one that like ChatGPT got wrong as well. So gather information. Which of the following topics concern identifying a problem? I'm going to go with gathering information. Because questioning the obvious is not identifying the problem. That's already troubleshooting. I want more information so that way I can identify what the problem is. All right.
A technician determines that a faulty network connection caused a system error. Which logical approach allows for methodical steps to diagnose the cause?
This one. All right. Teach me.
A technician is troubleshooting an issue with an employee's computer after a recent update. The technician asks the employee questions such as, has this setup worked properly before? And when was the last time it worked as expected? These questions help with which of the following troubleshooting approaches in pinpointing the issue.
To reinforce it.
Determining if anything has changed can help pinpoint a cause of failure. For example, if a system has experienced problems after a software update, the update is suspect.
That system's looking a little sus.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
No. I feel like that answer choice was not there. We're confirming the theory because the alert could be wrong.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help?
I just read this. Oh my gosh, dude. Why do I suck? Determine if anything has changed. Okay.
Troubleshooting steps includes open and closed approaches to obtaining information.
Which of the following? Oh, questioning the user. Open and closed approaches.
A technician tries the suggested troubleshooting steps to remedy a computer issue. The steps do not fix the problem. The technician discovers additional suggestions at a support website that provide a different cause and potential fix for the problem. What troubleshooting path should the technician follow?
Okay. A technician tries the suggested troubleshooting steps to remedy the computer issue. It did not work. The steps do not fix the problem. He goes somewhere else. If the theory is not confirmed, reestablish a new theory or escalate. Double it and give it to the next guy. Okay.
When following standard troubleshooting guidelines, an IT support technician asks a user, did it ever work? And when did it last work? These questions help with which of the following troubleshooting approaches when identifying the problem.
Okay. When following standard troubleshooting. Oh. You're trying to changes. You're trying to determine if anything has changed. Let's go. We're almost done.
A system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with application support personnel. In which of the following ways should IT troubleshoot the matter?
Verify full system functionality and if the application implement preventative measures. Man, dude, why am I going blank on these?
A system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with application support personnel. In which of the following ways should IT troubleshoot the matter?
Verify full system functionality and if applicable, implement preventative measures. See, I think it's this one. Because This is the problem. This is the solution. This is the theory. Now they need to test the theory. They already have a plan of action. It could also be determined if anything's changed. We're going to go with it. Yeah, it was determined if anything's changed. Man, I've gotten this one wrong like 4 times.
A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
Establish a plan of action to resolve the problem. Confirm the theory. I think this is a bad question. It's worded poorly. Establish a plan of action to resolve the problem and identify potential effects. So this has to do with the system contains an application that routinely crashes. They talk to the provider. They tell them to upgrade or to update. They update. So now they need to establish the plan. Let's see what it says.
Establishing a plan of action such as a maintenance window or scheduled downtime to fix an issue is best practice. Researching impacts of any fixes should also be considered.
See, this is the issue. And this is what makes it hard. Knowing, because like when people troubleshoot, a lot of time they do it all at once. And it's hard to know like where it all fits in the hierarchy. So they identify the problem. They have the solution, they have the theory. After speaking with the application personnel, they've decided to upgrade it. Now, the next step would be to establish a plan of action to resolve the problem and identify potential effects. Basically, to do it, to see if it works. I was thinking that they had already done it. This would be the step after this one.
A system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with application support. A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on...
Okay, here we go. It's the infamous question. Here we go. Confirm the theory. Establish a plan of action to resolve the problem. Oh, let's go. Oh my gosh.
Asks the employee questions such as, has this setup worked properly before? And when was the last time it worked as expected? These questions help with which of the following troubleshooting approaches in pinpointing the issue.
Changed. Test a theory, document establishing a theory. It sounds like he's establishing a theory, but he's determining if there's been change.
A system that contains custom applications routinely crashes. IT decides to upgrade the operating system after speaking with application support.
And identify the potential effects. Let's go.
Sysadmin do to help mitigate. A sysadmin is reviewing an alert for the firewall that a piece of malware was downloaded to a computer on the network. What steps should the sysadmin do to help mitigate this in the future? Select 2.
Oh my god, dude. Look, I got that thing wrong 4 times in a row, really. Wow. That one really got me. I don't like that question. I think it was a bad question. Sweet, I'm 84% done. And something that was supposed to take me like 20 minutes took me, I don't know, where am I at? Like 2 hours. Fantastic. I don't know if I'm going to stream later again today. I do have to get this one done today. Actually. Let's move this. 1, 2, 3, 4, 5. Yeah. I got to get... Yeah, I might just do one every single day. I don't know. streaming every single morning and studying this stuff might be the call to make sure that I understand everything. But this will be the next stuff. I'm almost done. Look at that. Woo. Okay. Anyway, I hope I'm gonna finish eating my breakfast, and there's other things I gotta do. I gotta cut down another tree and dig a hole and stuff outside. I might play some games later tonight, probably so. But yeah. Anyway, so like, follow, subscribe, do all that cool stuff. I hope you had fun. Hope you learned things. Oh, I didn't even realize that the music went away. There we go. So, have fun, do things, don't do anything I want to do, enjoy your life.